You know a question is serious when they say there is more space for your answer on the following page. Actually, this question is not too bad. So it is an excellent question, but we'll break it down and hopefully it'll make sense to you. So use calculus to find the value of k if this line, 6x plus k, is a tangent to this function. So let's just think about what that looks on a graph. So the function we're given is a positive quadratic. So something like that. Beautiful. And the tangent, or the supposed tangent, is 6x plus k. So now the gradient of the tangent is 6, which tells me on our quadratic it will have to be on the right hand side in order for it to have a positive gradient, right? Because if it was on the left it would be negative, but they've given us that the gradient is positive 6. Okay, but now this plus k, what that's telling us is it could be a line down here or up here or all the way down here. We don't know, right? We're trying to find the value so that it is tangent to our graph. So once more, if they said y equals 6x, we know the gradient is 6, like all of those lines I've drawn. However, we're trying to find the y-intercept, right, the constant to add at the end, to make it just touch our function. Just touch our function. Because if it is doing that, and it has the same gradient as our function, it is a tangent. So that's where we are heading. Alright, so tangent, once more, we know the gradient must be 6. To use that information, we need the gradient function. So the derivative of f of x, so derivative of x squared is 2x. Take the 2, multiply it out the front. So 1 times 2 is 2. Subtract 1 from the power to give 1. The derivative of plus 2x is plus 2. Right? The derivative of a constant times x is the constant. It is the gradient. And finally, the derivative of negative 1, or the derivative of any constant, is 0. Great, so we have the derivative, the gradient function. Now, we were told the gradient of the tangent is 6, which means the gradient of our function needs to be 6 at the point where they meet. So we can set our gradient function to 6. So 6 equals 2x plus 2. Great, and now we solve for x. So subtract 2 off of both sides, divide both sides by 2, we get x equals 2. So again, what this means, back to our sketch, is when x equals 2, the gradient of our function is 6. The gradient of our function is 6. So that's where we need to position our tangent line at that point. However, we are just given, or we just worked out the x value. So now we need to work out the y value. So let's do that now. So when x equals 2, f of x equals, I guess correct notation would be f of 2, just to show that I'm substituting 2 into the function f, right? 2 squared plus 2 times 2 minus 1, 4 plus 4 minus 1, which gives 7. So what this tells us, again, back to the sketch, is that we need our tangent line to intersect that point, 2, 7. So therefore, tangent intersects f of x, our original function, at the x value of 2 and the y value of 7. Because if it doesn't, it can't be a tangent to the graph. Okay, so where to from here? Oh, thank goodness we have extra space on the following page. So, equation of the tangent, let's just write that down here, 6x plus k. We know that this tangent line must go through this x value and this y value. Right, it is a point on the line. And now you'll see we can substitute that in for x and y and solve for k. So let's do that now. So in for y goes 7, in for x goes 2, 7 equals 12 plus k, subtracting 12 off of both sides, k will equal minus 5. Alright, and was that the question? Yep, find the value of k. Good. Always reread the question because you can get a bit lost in your own working sometimes. So let's go over this one. Where to start? Right, so we're looking for the value of k, which is part of the equation of the tangent. So to get there, we need the derivative, f prime of x, which we found. We then set it equal to 6, right? And we did that because we know the gradient of the tangent is 6. And so in doing that, that is an achieved skill. You found the derivative and then you use some information to try and use it. So we then found the x value, where that x value is where our function f of x has a gradient of 6. We then use that x value to find the y value of that point, right? And we then concluded that the tangent must intersect at that point, because that's the point on our graph where the gradient is 6. Then we use that point back into the equation of the tangent and solved for k, right? Solved for the y-intercept. And in getting that correct, we got excellence. Hey!